Hey guys, we're going to talk about graphing systems of equations today. And a system of equation is basically a group of equations that you're going to have to graph and determine where they cross in order to find their solutions. So we're going to start out with graphing, and there are two other ways that we'll solve these systems as well. So the first one is graphing, and if you look at this first problem in your note-taking guide, and here it is on the screen, we want to solve each system by graphing, and we have y equals 6x plus 4 and y equals x minus 1. Well, these equations are both in what form? Slope-intercept form. So both of these are in slope-intercept form, which makes it very easy for us to graph these. So if I look at equation 1, and I'll just call that the top equation, this first one in blue. It'll be y equals 6x, here, y equals 6x plus 4. Well, we can very easily identify what our slope is and what our y-intercept is. Our y-intercept is 4, and our slope is 6. So I'm going to begin at 4, so I'm going to plot my point right here at 4. And then my slope is 6. So that means I can rise 6 and run 1. But if I rise 6 here, I'm going to run out of room on my graph. So instead I'm going to go down 6 and to the left 1. So it should look something like this. And then I will draw my line and to connect the dots. So that it looks something like this. And so I have one of my equations graphed, but I need two because this is a system. So let's do this one in orange. So I have y equals x minus 1. It's my second equation in the system. And so I need to determine what my slope and my y-intercept are once again. So if I determine that, I would say that my y-intercept is -1. And my slope is 1 because there is not a number in front of x, so I automatically know that that is 1. Now I just have to put it on the graph. So let's do that now. I should begin at -1. And I'm going to rise 1 and run 1. So rise 1, run 1. Now if I keep rising and running 1 to the right, am I ever going to run into that blue line that I've already graphed? No. So what I'm actually going to do is I'm going to go down 1 and back 1 so that these two lines will actually intersect. Now, it's important to go all the way across the graph because if you don't, you may intersect inaccurately and your lines and your points might not match up. And so your answer could be incorrect. So I draw my line and I'm looking for where these two lines cross. That's going to be my solution. So my solution is actually a point. It's an x and a y value. So this point where they cross is going to be -1, -2. So that's where these two lines cross. That is the solution to our system. So that means that when x is -1 and y is -2, both of the conditions of these equations would be satisfied. So our solution to the system would be -1, -2. Okay, graphing, you should be able to do. You're putting two lines on a graph. So look at this next one. It's number 6 in your packet. So if I look at number 6, are these two equations in slope-intercept form? No, they are in standard form. So I have to deal with that before I can deal with anything else. So I'm going to go over to the side, and I'm going to deal with the top equation first. So equation number 1, 7x minus 2y equals -8. Now, this isn't in slope-intercept form, but I can get it that way. So if my goal is to get it that way, I need to get y all by itself. So if I'm getting y all by itself, what I'm going to do is I'm going to subtract 7x from both sides to get -2y equals -7x minus 8. Following that, I need to divide by a negative 2, because negative 2 and y are being multiplied together. So I'm trying to get y by itself, remember, which leaves me with y equals. Now a negative 7 divided by a negative 2 will give me positive 7 over 2x. And then negative 8 divided by a negative 2 will give me positive 4. Now I have the slope-intercept form of this equation with my y-intercept being 4 and my slope being 7 over 2. So I'm ready to graph. So I'm going to go up to 4. Now I can't rise 7 and run 2 this time because I will run out of room in my graph, but I can go down 7 and to the left 2. And this is what my line should look like. So then I connect my 2 points. Well, the line a little better than that. And draw my arrows. Arrows are important because they're going on forever. All right, one equation down, one to go. So again, this other one that we have to graph is not in slope-intercept form, but I can get it there. So I have number 2 is 7x minus 2y equals 4. So, thinking about that, I need to solve again for y. So I'm going to subtract 7x from both sides. So I get negative 2y equals 4. I'm sorry. Will equal negative 7x plus 4. And now, again, I need to divide by negative 2. So when I divide by that negative 2, I get y equals 7 halves x minus 2. Alright, I'm going to graph this in a different color, not green, because we already have a green line. So how about navy blue? We will graph in navy blue. So I'm going to begin with b as a negative 2, and my slope is 7 over 2. So if b is negative 2, and I rise 7 and run 2, should look something like this. Here's my question. Are these two lines ever going to cross? Well, based on my graph, I would say no, they're never going to cross. And if you look at their slopes, what do you notice about the two slopes here? I have 7 over 2 and 7 over 2. The slopes are equal. When the slopes are equal, this means that the lines will be parallel. So if the lines are parallel, we know that they're never going to cross, which means the solution to my system is actually no solution. Now there is one other type of system. We're not going to graph it, but I'm going to talk about it with you. If I graph one of these lines, and then I graph a second line, and the lines line up exactly on top of each other. So it would look something like if I set up and had this graph, and let's say that my first equation was something that looked like this. And that's my first line. Great, fine, awesome. But then when I started graphing my next equation, it looked like this. The points lined up the same. When I went to graph it, everything wound up lying directly on top of each other. Would you agree that all of the points on this graph match up? I would say so. There are actually two lines there, but they're matching up perfectly. So what we would call this is, because these lines are going to touch forever and ever, we would call this solution infinitely many solutions. Because the lines are touching in infinitely many places. And the solution to a system is where they cross. So if they're crossing over and over and over again, it's going to be infinite. All right, so those are your three types of solutions. You can have one solution, which will give you a point. You can have no solution, which means the lines are parallel. Or you can have infinitely many solutions, which means your lines are coinciding, or they're lying directly on top of one another. All right, good luck practicing these systems of equations with graphing.